Problem 98. Find the distance you must sit from a movie screen that's 8 feet off the ground and 30 feet high to maximize your viewing angle. So based on this diagram, we want to maximize A. So our first goal in that is to get some relations between the angles and the sides of the triangle. So I see, first off, focusing on this lower triangle, that tangent of B is 8 over x. Focusing on the whole big picture, tangent of A plus B is 38 over x. Now, neither of these two equations involve just angle A. So what I'm going to do is use a trig identity to break apart this second tangent function. I'm going to use the fact that tangent of A plus B is equal to tangent of A plus tangent B divided by 1 minus tangent A times tangent B. Now tangent A plus B we have from above is 38 over x. On the right hand side of the equation, tangent A is unknown, that's what we'll be solving for. Tangent B we have is 8 over x. In the denominator we can make the same substitution. So this is tangent A times 8 over x. Now let's get rid of this compound fraction next by multiplying both numerator and denominator by x. We distribute this through, and on the right hand side of the equation we've got x tangent A plus 8 divided by x minus 8 tangent A. Let's cross multiply to get rid of fractions. This gives us x squared tangent A plus 8x equals 38x minus 304 tangent A. I want to solve this equation for tangent A, so let's first move all the tangent A terms to the left-hand side of the equation. So this gives us tangent A times x squared plus 304. And we'll move all the non-tangent A terms to the right-hand side. So this gives us 30x. Finally, we'll divide to get the tangent A by itself. So we have that tangent A is 30x divided by x squared plus 304. So now we have A completely in terms of this side x. And now we're ready to maximize A. So remember, to maximize, we're looking for critical numbers. That happens where our derivative is 0 or where it's undefined. So we'll begin by differentiating this equation with respect to x. On the left-hand side, the derivative of tangent A is secant squared A times dA dx. On the right-hand side, we've got to use the quotient rule because these are being divided. So we'll square the bottom, x squared plus 304 squared. In the numerator, we've got the bottom times the derivative of the top. So this is x squared plus 304 times 30 minus the top times the derivative of the bottom. So 30x times 2x. Simplifying this a little further, this gives us 30x squared plus 9120 minus 60x squared divided by the same denominator, x squared plus 304 squared. We can now combine like terms in the numerator to write this as negative 30x squared plus 9120 divided by x squared plus 304 squared. And this is all equal to secant squared A times dA dx. And I want to know where dA dx is 0, so what I'll do is set dA dx equal to 0. So that is convenient because it gets rid of the secant squared A. 0 times anything is 0. And it gives us this new, easier equation, negative 30x squared plus 9120 divided by x squared plus 304 squared, but I'm going to multiply both sides of the equation by this denominator, so we're left with this quadratic. And we can solve this by moving the 30x squared to the left-hand side of the equation. Now divide both sides by 30, so x squared equals 304. And this tells us that x is the square root of 304, and that's approximately 17.436. Now we want to know, is this a maximum or did we find a minimum? So to determine if this is a max or a min, what I want to do is do the first derivative test. So I'm going to put in our critical number here, x equals 17.436, and choose a number on either side of this critical number. So on the left, I'll choose x equals 17. On the right, x equals 18. And plug each of these into what we have for the first derivative. So our first derivative is dA dx equals negative 30x squared plus 9120 over x squared plus 304 squared. And I want to take this equation that we had and divide both sides by secant squared. And that gives us cosine squared a on the right-hand side. Now if we plug in x equals 17, x equals 17, we have dA dx equals positive 450 divided by, well, anything squared is positive, and cosine squared is also positive. So we have that the first derivative is positive. So we know that our function is increasing all throughout this interval. If we look at x equals 18, we have dA dx equals negative 600 divided by, again, a positive number because our denominator is squared, times a positive number because cosine is squared. So we have that our derivative is negative, so we know the function is decreasing. So this actually is a maximum. So our maximum occurs when we sit about 17.436 feet from the screen.